Hello everyone, in this section we are looking at remote sensing platforms and sensors. Remote sensing platforms are stable and firm platforms upon which remote sensors are mounted for imaging. And depending on the intended use and the application of the sensor, it can be ground-based that can reach up to 150 meters, or airborne-based that can also reach from 10 to 12 kilometers, and also spaceborne-based that can also reach from 700 to 900 kilometers. Spatial resolution and area of a sensor coverage or observational view increases as the sensor's platform height increases. Mostly, remote sensing platforms are satellite and aircraft, radio-controlled aeroplanes, drones, balloon kits for low-altitudes tasks, ladder trucks or cherry pickers for ground investigations. Orbit is the path that satellites follow in the course of viewing or imaging targets. And satellites' orbits relate to the capability and the objective of the sensor mounted. And orbit selection can be determined by altitude above the Earth's surface, orientation, and rotation relative to the Earth's surface. Orbit types we have the medium Earth orbit, which is MEO. Geosynchronous orbit, which is GSO or geostationary orbit. We have the polar orbit. We have the Sun synchronous orbit and highly elliptical orbit. Details of each of these orbits can be found in the reference materials that will be provided after this section. Spatial resolution in terms of digital images. Spatial resolution refers to the number of pixels utilized in the construction of the image or the spatial density of the image. It implies the smallest object or pixel that a single sensor can detect on the ground. The recognizability of this detected object is another issue. Spectral resolution is the number or location of spectral bands a sensor collects data, and it is how wide the bands are. The portions of the electromagnetic spectrum to which the sensor is sensitive to its bands can also be referred to as spectral resolution. These bands can be multiple for some sensors and have different widths. It is the width of each band that determines the spectral resolution. Radiometric resolution helps measure the sensitivity of the sensor to be able to detect reflected electromagnetic radiation. In other words, it is the ability of the sensor to distinguish different grayscale values. It is measured in a bit. The more bits an image has, the more grayscale values can be stored. Thus, more differences in the reflection on the land surfaces can be spotted. Passive sensors detect natural energy that is emitted or reflected by the object or scene being observed. Reflected sunlight is the most common source of radiation measured by passive sensors, as you can see in the diagram here. Active sensors, on the other hand, provide their own source of energy to illuminate the objects they observe. An active sensor emits radiation in the direction of the target to be investigated. The sensor then detects and measures the radiation that is reflected or backscattered from the target, as you are also seeing it here. For more information, you can visit this link. Visit these sites for free remote sensed imagery repository from the Earth Explorer, USGS, and the Copernicus mission. Here is a list of references for further reading. Thank you for your attention.